Okay, now we're going to create some box and whisker plots to also look at variation, skewness, and comparing the graphs. So here's our data set again. And the 5-number summary, if you recall, is the minimum, Q1 or quartile 1, the median, quartile 3, and the maximum. So we go to Stat, Enter, or Edit. Right, and I've already put in the information for the first set of data. And so now I'm going to hit Stat again. And this time I'm going to go to Calculate. And I'm doing that first one var stats, one variable stats, and Enter. And it's in my first list. And I enter through to calculate. And so I want to write down this information. Again, whenever I do any of these calculations, I want to write down all the information before so that I have it readily available to use if I need to do any other calculations or any other information. So I'm just going to write this here. So the mean is 10.13, again rounding to 2 decimal places. The sample standard deviation is 0.12. The population standard deviation is 0.11. And then I'm going to go ahead and write the mean or the minimum, the quartiles down here because I need those for our 5-number summary. So we have a minimum is 9.92. The first quartile is 10.07. The median, so I got to arrow down to get the rest of the information. And when I arrow down, I end up with the median of 10.14. I also have the third quartile, which is 10.2, and the maximum is 10.38. And again, these are all in seconds. I've gone ahead and done the other information, and I'm going to write those down appropriately. So for the second data set, we can see the mean is a little bit higher. And notice that the standard deviation numbers are also greater than the standard deviation numbers. And we'll define standard deviation in just a second here. Also, when we look at the 5-number summary, we have the minimum, the quartiles, first and third, the median, and the maximum. So a box and whisker plot, and we're going to graph these on the same number line. Here's our number line. That's a very crooked number line. Let's try this again. Again, we need to label our number line. So this is time in seconds. And we need to go from 9.9 to actually 9.89 to 12. So I'm going to start with maybe 9.5. And I can count by maybe 0.2s. So 9.7. And so on and so forth. Okay, so for the first set of data, so the minimum is, and the maximum are the whiskers. And then the box is made up of the first quartile, the median, and the third quartile. And so the minimum and maximum, so we have 9.92, so that's approximately here. And we're going to label as 9.92 so that we know. And then 10.07 is about right here. So this is our the beginning of our whisker, the beginning of our box. And again, we're going to label this 10.07 so we know what those values are. And then 10.14, so that's just beyond. So now we have 10.14. 10.2 is the end of our box. So our box is connected. Okay, so there's our box, and then the rest of the whisker is the maximum, 10.38, which is about right here. So this is a very small box and whisker plot, which means it has very, very low variation because they're all compiled nearest to, in this case, the median. Each whisker is about the same length. This whisker on the right-hand side is a little bit longer. Again, our median is 10.14. Our mean is 10.13. So this is a very symmetrical graph that might be just slightly skewed, but not anything to be concerned about because the mean and the median are about equal. Now, when we look at the other graph, 9.89, so that actually starts about right here for 9.89. And then we have 10.38. Oh, I'm sorry. Yeah, 10.38, which is the same 10.38 for the maximum here. So we have 10.38 is the beginning of our box. This is all the whisker. And then 11.2 or 11.02, so that's about just before the 11.1, so somewhere right here. And then 11.66. So now we have our box. And then the whisker ends at 12, which is approximately right there. Notice how this is much more spread out. It is, so this has high variation because it's spread out. So you have a very long box and whisker plot as compared to the shorter box and whisker plot for the first set of times. Our median is 11.02. Our mean is 10.98. So 10.98 versus, again, 11.02. So it's fairly symmetric. It might be skewed just slightly to the left-hand side because the mean is just slightly smaller than or less than the median. But again, the length of each one of these whiskers is about proportional to the rest of the box and whisker plot. So now what's standard deviation? So standard deviation is there's three types of standard deviations, but standard deviation is the spread about the mean. So the variation or the spread in relationship to the mean. In the box and whisker plot, we were looking at the spread as it related to the median. In standard deviation, we're talking about the spread as it is in terms of the relationship to the mean. And there are three types of standard deviation. We've already talked about, or we've looked at two of them. We have the sample standard deviation, we have the population standard deviation, and we also have what we call an approximate standard deviation. And this is calculated by taking the range and dividing by 4. So there's actually three different standard deviations. Sample, which is what my math lab is going to look for in terms of an answer. The population, which is what we're going to use for the normal curve, which is next. And then the approximate standard deviation is really just a quick way of finding how spread out the data is to the mean, with the mean being your measure of center. So if we look at our two standard deviations, and again, we had 0.12, 0.11. We also had 0.72 and 0.70 in terms of the standard deviation. So the fact that these numbers are much smaller than set number 2.7, this means that we have very low variation again. We have higher variation with the larger number. In other words, there's more, it's kind of like the margin of error. There's more plus or minus, if you want to call it wiggle room, in set 2's data versus set 1's data. So there's very little wiggle room around the mean. So it's 10.13 plus 0.12, 10.13 minus 0.12, 10.98 plus 7.2 versus 10.98 minus 7.2. So there's larger variation in the set 2 than there is with set 1. And then so that's one way of talking about the meaning of that. So we know that, and again, all of these values, so this indicates low variation. And again, all of these values are in seconds. And as we're comparing against each other, then this is a high value variation. And again, this is around the mean, not the median, but around the mean. And these, again, are all in seconds.